Alright, so we're gonna be working with numpy, and for that we need to go to the numpy main page, go where it says install, come over here, copy this command, then go back, and in the terminal you have to paste the command and hit enter. I'm not gonna do that because I already did it, and you will have to accept the terms. Just type Y and hit enter. And now that we have numpy installed, we need to come here. We have to, if you don't wanna, it's okay, but I'm gonna create a new file called test.py just for testing. And now I'm gonna import numpy, but we are gonna be renaming numpy as np, just as a shorter version. It's the exact same, but with a shorter name. Okay, and now I like to copy this list. Okay, copy it and go to test and close this one and paste it here. And I'm gonna be pasting it twice and rename it as circle X. Why circle X? Because I'm gonna be redefining this list as a numpy list. A numpy array. So it's np.array and surrounded with parentheses, just like that, and that's it. Now it's a numpy array. So we're going to be printing the size of each number of each element, each one of these. Okay, for that we need to import a library called sys, and down here we say sys, and we're gonna be calling a function called get size of, and we're gonna be passing one of these numbers as an argument. For example, from the first list circles in the we're gonna be passing from the third element the index 1. So the third element is 2 and the index 1. And we're gonna do the same for the new list, which is circle X. Save it and see what we get. Okay, it's Python test. So we're getting test result 28 bytes for the first list and 32 bytes for the second list. Now, the advantage of using numpy is that we have more controls over the size, over the memory size that's being used for storing one of these numbers. For example, we say comma the type, and what's the data type that we're gonna be using for creating or initializing this array. So it can be, for example, integer 16. But for that we need to say np.integer because it is a type inside numpy. Save it and see what we get. Now we are getting the result 26 bytes. Okay, but this is not the size of this is not the actual size of the number. This is the size that Python is using for storing more data, not just the number. It's the functionality that comes with it. Okay, so if we want to access the real size of the number, we have to say something like np.dtype and then open parentheses, and then we are passing one specific item, for example circles X, because it is the name of the numpy array, and then we're passing for the same, can't see, the same 2 1, say it's gonna be 2 1 and then dots, and what was it, item size, just like that. Save it and let's see. It says we have 2 bytes, so each one of these numbers occupies 2 bytes. Okay, so but what if I say int 32? Save it. Now we are occupying 4 bytes, which makes sense. And we can even say something like float 16, which is a half precision number. It says 2 bytes, okay, but a float must be something around 32 bits, and we are getting 4 bytes again. Okay, so that's the purpose of why most people use numpy, is for having more control over the size of the data, or maybe more accurately would be saying having more control over the memory usage. Okay, so now we can go to, okay, let me exit. Okay, now we can go to numpy again, go where it says data types, and down here we have a detailed description of each data type. For example, numpy.int32, it says platform defines integer type with 32 bits. And down here we have numpy int32 or numpy int64. It says platform define integer type with at least 32 bits. Okay, and for example float 16, it says that it's not available for C. It's a half precision float sign bit. Okay, and for example numpy float 32 in C, this is what we call a float, and float 64 is what we call a double, which means we have double precision. Okay, this means that we are using 52 bits mantissa, which mantissa is basically telling us how much decimals are we getting. Yeah, those numbers before the decimal or before the floating point. And yeah, that's it. You can come over here and check the documentation and see what else we can do. We can even create new arrays. Okay, now I like to go back and go to the getting started. So go to documentation, getting started. Yeah, so here it says, it tells us the definition of an array. So basically it's just a matrix. We can have a one-dimensional array, which is a vector, in other words, and a two-dimensional array is something like a table or a matrix. Okay, and we can have multiple dimensional arrays. Okay, something that we wouldn't be able to see in a single table like this one, but we would see it in a three-dimensional animation or something like that, or maybe not. Yeah, there are n dimensions that we can work with, and yeah, that's it for now. Okay, so see.